And as you can expect, that approach worked. And you know by now that it worked until it didn't. My name is Rafael Bottino, and welcome to Rafabot Cloud Tips. Today we're going to talk a little bit about AWS Step Functions. I'm not sure if you've seen this service before, if it's your first time hearing about it, if you've played with it before, or if you have some experience with it. Well, I actually played with it not that long ago, and I would like to share my learnings with you. We're going to talk about the basics of AWS Step Functions, such as what it is, the basic terms, but also some of the key limitations that I hit while I was leveraging AWS Step Functions to solve my business problems. So let's see what AWS Step Function actually is. Well, what a better place to start than the AWS Step Functions documentation. And sorry that's boring, but I want to read what is written here so we can try to break it down. AWS Step Functions is a serverless orchestration service that lets you integrate with AWS Lambda Functions and other AWS services to build business-critical applications. Step Functions is based on state machine and tasks. A state machine is a workflow. A task is a state in a workflow that represents a single unit of work that another AWS service performs. Each step in a workflow is a state. Okay, a lot of beautiful words here, but what exactly does it mean, right? I actually jumped something here on purpose. Through Step Functions graphical console, you see applications workflow on a series of event-driven steps. The AWS console for AWS Step Functions is actually really cool and helps you build your step functions from the ground up. Usually, I don't recommend you to build anything on the AWS console. Usually would recommend you to use infrastructure as code such as CloudFormation, CDK, Terraform, Pulumi, whatever flavor is. But in this case here, AWS Step Functions dashboard can be really useful even for you that is building your IAC, since you can export whatever you build from the dashboard in code so you can import in your IAC. Let's check it out. So this is the AWS Step Functions console whenever you log in there for the first time. Let's see state machines. So state machines, like we saw before, are workflows, right? A state machine pretty much defines what your business logic looks like inside of Step Functions. What do I mean by that? So let's say try to create our own. First, whenever you click here to create your own, you're going to see choose authoring method. Because it's the first time you're doing this, and honestly, even if you have some experience, I still recommend this option. Let's pick design your workflow visually because it's so neat, as you're going to see. Then we have type, standard or express. If you click help me decide, you're going to see that it's pretty clear which one you should pick based on your needs. For instance, if you need to run something for longer than 5 minutes, you're not going to ever pick express, right? You're going to pick standard. But now, if you're thinking of a pricing economic perspective, Express usually is more reasonable to run than the standard version, right? So it's really up to you. If you have the hard requirements that are not matched by the Express version, go with standard. However, if either would be fine, I highly recommend going with Express. So that's what we're going to do here today. Whatever you do, you're going to see this screen. And as you can see, there's a big drag first state here in the middle of the screen. It's as simple as that. You can actually build some really cool stuff here without even coding at all. So let's say that we want to create a workflow where we're going to list all the objects on a bucket per object, we're going to go and tag this object, and then we are going to email using Amazon SES a specific email address to let it know that that job is done, that job is complete. How will we do that here? At least on a high level, right? We can come here and go for S3 list objects, right? So we're going to list objects here. Now we need to run something once per object that is a result of that list. Then we have map, which runs parallel workflows for each item in a dataset. So based on the list of objects that are going to be generated from this bucket, my data, for instance, we are going to get to this map state. And for every single one of them, we want to put object tagging, right? So for that bucket in that key, we want to add a specific tag, right? Again, not going to the details here because that's not a tutorial on how to build your own. It's just to give you an idea of what step functions look like. But it would be something similar to this, right? And whenever it finishes going through all the objects and putting the tags, we can have send email. And then finally send the email and terminates the workflow, right? The cool thing is here that we have definition. That's a language specific built on top of JSON, as you can see, specific to step functions. But whatever IEC you're using, you can actually just copy this and import in your IEC, right? So really, really useful stuff. I actually had a problem recently, like I mentioned before, where step functions made a lot of sense to me, right? I had a similar problem where I needed to list all objects on a bucket and do something per object once and move on, right? Really similar to what I just did here. And while doing that, I actually learned a lot about step functions that I want to share with you today. So AWS Step Functions, amazing service. It's really intuitive to use, as you saw here, really easy to understand what you're doing. Drag and dropping couldn't be easier, right? Sure, it can get a little bit more challenging when we go and added all these different parameters, but it's not that hard, honestly. And you can actually do a lot without even writing a single line of code. Awesome. But there are limitations that you should be aware of. So let's talk about it. I actually wrote an article about this a while ago, and I'm going to use that here to show you some of the limitations that I wrote about before. So first, let me tell you exactly what was my problem and what my first approach was without using step functions, and why I realized that I actually had to use step functions to solve my problem. Like I said before, really quickly, on an object, whenever an object was created, I had to generate a pre-signed URL. I would push that URL to a queue, a SQL, and that was it, right? And something else was dealing with the queue. But there was this need where I actually wanted to go through all the files and generate the pre-signed URL and then push the queue, right? So instead of waiting on an object created, I wanted to go over all the files. So I adapt my Lambda code to be really simple. It would start, it would look if there was an object in the bucket. If there was, it would generate a pre-signed URL, push to the queue, and move on to the next one. If there was still an object, it would generate the pre-signed URL, send to the queue, and so on, until there was no objects left to generate a pre-assigned URL for, and then it would end execution. And at first, well, it worked, right? Really simple code. It took me like 5 minutes to change what I had to this new one, and that was it. It was working. Until it wasn't, right? Because even though that was working, it was working for a limited amount of objects. The moment that I added a good amount of objects to that bucket, an amount that was big enough, my Lambda would time out. I could push 30 minutes for timeout limit, which is the Lambda limit. I could add more memory to it, which as you might know, it also adds more CPU and actually even network bandwidth, some say, based on tests, of course. And still, it would time out. So I knew that was a bad approach. And that was actually the perfect excuse to go and start to learn AWS Step Functions. So that's what I did. I changed my approach using AWS Step Functions to do the following. I would list all objects on a bucket, just like we did now. And for every single object, again, just like we did, I would then invoke that original Lambda that I had, where it would pre-assign the URL and then send to the queue. Now, the Lambda wouldn't time out anymore because I knew that would work really well for just one object as it was before. And I was taking the heavy lifting of listing objects and sending that to Step Functions. And even better, it would parallel the execution of that Lambda, making it run faster. And it actually did. It was running way faster than my approach before, and it was working once again. But of course, until it wasn't. I hit my first AWS Step Functions limitation. Using this drag and drop integration with different services in AWS is awesome. It's easy. It just works. However, you might be familiar with a concept called API pagination, right? Whenever you make a request, you're asking, in this case, for all objects on a bucket. By default, it actually returns you 1,000 objects only and a token to the next page, therefore pagination, with the next up to 1,000, right? And you keep doing that until you go through all the objects that you have on a bucket. And you know there is no objects anymore because there isn't a next token anymore, right? There isn't a token to the next page. So the approach here, so the way it works in AWS Step Functions, whenever you're using one of those native integrations, it actually doesn't do pagination on your behalf. So you need to go around that. So my code worked up to 1,000 objects. So I had to change my approach again. So I dropped the direct to service integration like I was using, and instead I replaced it with a Lambda of my own because I could do the pagination on my own Lambda. So I created a Lambda that was going to list all objects in a bucket. Whenever I had all the objects on that bucket, then I would with that output of the Lambda, that would feed my map state. And for every object in that list of objects, then I would run my previous Lambda that was going just to pre-assign the URL and send to the queue. And again, it worked until it didn't. It worked for more than 1,000 objects, which is awesome. But again, I hit a limitation with a few thousands. And the limitation was the execution reached the maximum number of history events, which is 250K, right? 250,000. I didn't get it. What is a historic event in the first place? Well, the documentation actually says that there is a hard limit, a hard quota of 25,000 entries in the execution history. So whenever you're executing a workflow, a step function, on that execution, it cannot generate more than 25,000 events, right? And that's a known limitation that I didn't know about. And hopefully now, if you didn't know, now you do, and you're not going to run through this problem. But how do you solve this problem then? The documentation actually suggests implementing a pattern where whenever you're close to hitting that number of events, you actually start another workflow continuing where that first one left off, right? So if you can rework your code to start executing, and then whenever it's close to hit the limit, stop, and start a new workflow from where it stopped and continuing doing what it was supposed to be doing, that's the perfect scenario, right? So here the idea would be execute the pre-signed URL Lambda for up to however many objects I need to almost hit that limit, stop the execution of the workflow, restart the execution of the workflow from that object on, right? So let's move to actually a second article that I wrote, because it took me a while to write the first one and I wanted to publish even before I was able to solve this problem, because for the use that I had, actually that limit was kind of okay, but of course, knowing there was a limit and there was a way around it, I wanted to push forward and see what else I could build. So let's check my second article here to see how I solved that problem. So as you can see here, that was what I had in mind, right? I didn't build this, it was just in my head in a notebook. What I wanted to do was have a list objects workflow. I would start that one, it would list all the objects, and then for each 100 objects, it would start a scan object workflow. So now instead of having just one workflow, instead of just having one step function, I will have two. One for listing and one for scanning. And then the listing would trigger the scanning once per 100 objects, right? So that's what I had in mind. So it would be something similar to this, at least for the first one. But I actually changed it slightly. I did a step function that would just list all the objects, and then it would pass all the objects as a parameter to another step functions, right? Another workflow. And that's the scanner flow that I mentioned. But it's slightly different. Instead of just receiving 100, it would receive all. And that scanner would look like this. It would filter the first 500 keys to scan, or up to 500. And in parallel, it would do two different things. One is what you kind of expect, a map of the 500. So once per the 500 objects, it would scan that object, would generate the pre-signed URL object and push that to the queue and move on. But in parallel, it would see, wait, I had 500 keys out of how many? Oh, there are still keys left? If there are, re-execute this workflow. So it starts a new workflow based on the same step functions, to be more clear, with the remaining keys. So let's say I had 1,000 keys before. Now it's going to restart these step functions as a new workflow with the next 500, right? Or better saying, with the original 1,000 keys minus the first initial 500. If there were none left, then it would simply stop, right? So as you can see, that is going to trigger this same step function multiple times, however many times it takes to go through all the objects divided by 500, of course, because that's the batch that we're processing each time. And as you can expect, that approach worked. And you know by now that it worked until it didn't, right? Because I hit another limitation that I want you to be aware of. That is the payload size that both AWS Step Functions and AWS Lambda can support. So if I open here this link and this one, I can show you that previously AWS Step Functions had its payload increased to 256 kilobytes. And if we search here for payload, we're going to see that for a synchronous request, which is what we're doing, we're not waiting for an answer of that Lambda that is generating the pre-signed URL. The limit is 256 kilobytes, right? So if we go back here to this diagram, I can actually show you where we are hitting this limit right away. We are hitting this limit over here. If we had a long enough list of keys to go through this process, even removing the 500 keys that we want to scan, we would have a JSON object with two lists of objects, one to go through the process and then the other part to move on to the right side of this diagram. That JSON object was bigger than 256 kilobytes, right? So for a bucket that had enough objects, this wouldn't work as well because of the payload limit. So there is actually a suggestion by AWS, again, to avoid going through this problem. And the recommendation is actually using Amazon S3 instead of passing large payloads around. So again, instead of passing that big JSON that was bigger than 256K or potentially bigger, because you never know, depending on what you have, of course, you never know if you would grow that long, that big. Ideally, you don't pass that JSON object. Instead, you write that to an S3 bucket as an object, of course, and then you pass a reference to that object. You pass the ARN of that object and have whoever needs that information read that information from the S3 bucket, right? So again, if you ever feel like you might be able to hit the payload limit, don't pass payload around other than saving that payload to an S3 bucket and passing the ARN of that object to the next stage of this, the next step, of the step functions or Lambda function, right? So that's pretty much it. Hopefully you learned a bit about AWS Step Functions today. And if you're already using it or planning to use it and had some research done already, hopefully I was able to also let you know that even though there are limitations for AWS Step Functions, and hopefully learn a couple of them today, it's a great service. You should be using it if it fits your business case, but please don't forget there are limitations. Be aware of them and develop with having them in mind. My name is Rafael Bocino. This is Rafa Blood Cloud Tips. Thanks so much. See you next week.